Hi you guys, today I'm going to talk to you about percent composition. So you'll need a pencil, calculator, highlighter, and your periodic table today. Okay? Alright, then let's get started. Percent composition. A percent composition is a compound is analyzed and the percent by mass due to each element is determined. Basically, you are trying to find the percentage of each element. And don't forget, that is, whenever you're talking about percentage, we are saying that that is part over whole times 100. That's what we're actually saying. Okay? So, and this is for each element. So that's a really big deal. You're trying to get the percentage of each element. So whenever we talk about percent composition, think of it as if you're talking about maybe portions. Okay? We're talking about maybe there's division in there. There's always 100%. If that even bothers you, then think of it as in fractions, part over whole. Okay? So the formula is given the formula of a compound, it is possible to determine the percent by mass of each element. So this is the formula that we have for the percent composition of each of the elements that we have. So you are going to take the number of atoms of an element, that's the part, and then you're going to find the atomic mass of the element. That can be found on your periodic table, so your PT, divided by the molar mass of the compound. Now this is the compound, that is the whole that I'm talking about, times 100. So this is the basic premise of percent composition, finding the percentage of each element. So let's do our first problem. It says here, find the percent composition of sodium carbonate. So sodium carbonate is this. You should get this as your formula. Okay, and when you find the molar mass of sodium carbonate, and remember, you find the solar mass using your periodic table, and I'll go ahead and find it for you up here, but it is 2 sodium atoms. Each sodium atom, if you go onto your periodic table, you are given the mass right here. This is what we're looking at. So the mass of a sodium is 22.99 plus 1 carbon atom. The mass of each carbon is 12.01. The mass, there are 3 oxygen atoms. The mass of each one, 16. And then when you plug and play into your calculator, you should get 105.99 grams per mole. So keep in mind that that is saying that there is 105.99 grams for every 1 mole. 105.99 grams for every 1 mole. Okay? So when we find the percent composition for this, we are going to have sodium right here. Okay? Sodium. And we're going to follow this formula. There are 2 sodium atoms. Each sodium atom has a mass of 22.99, which I did calculate from my periodic table, okay, divided by the total mass, which is 105.99, okay, times 100. And you should get 43.38% of sodium, okay? That's of one element that is in sodium carbonate. Let me make it smaller. There, you can see everything. So now let's go for the carbon. To determine carbon, you're going to do the exact same thing. There's 1 carbon atom. Each carbon atom has a 12.01, and divided by the molar mass of the entire compound times 100, and that should give you 11.33% of carbon that is in this compound. Okay? And then we have oxygen. Oxygen is, you have 3 atoms of oxygen. Each one is 16 grams per mole. The total mass of this is 105.99 grams per mole times 100. And that should give you 45.29% of oxygen. Okay? So when you add all of this up, all 3 of these, you should get a total of 100%. You could also just calculate these 2, and when you just calculate these 2, remember when we're talking about a percentage, we're talking from 100%. So you could do 100 minus 43.38 plus 11.33. And when you get that, you should get 45.29% of oxygen. So that's just another way of getting the exact same number. You can always check yourself by adding up all the other percentages. And all 3 percentages, 43.38 plus 11.33 plus 45.29 should equal 100%. So you can check yourself. Keep in mind, you guys, that when you are not given sig figs, then the number of sig figs will be based, you can't really base your sig figs on anything. So what you're going to do is you're going to have 2 places past the decimal is going to be your answer. So I'm going to write it here in a different pen. So keep answer. Okay, 2. Keep the answers 2 places after decimal. Okay? Okay, so let's go on. This is one of your formulas that you had: percent of element, number of atoms of the element times the atomic mass divided by molar mass times 100. Your second formula that you have is the percent of an element equals the mass of the element divided by the total mass of the element times 100. And this is when, let's say that you have a problem where you have the mass, okay, where you have, problems may give the mass due to each element, okay? So you're given a mass in the sample and you need to find the percent composition this time. Okay, so here we have a problem. 50 gram sample of an unknown hydrocarbon is analyzed. It contains 41.33 grams of carbon and 8.67 grams of hydrogen. Find the percent composition. So you're given a whole bunch of stuff on here. And hydrocarbon, remember that's your hydrogen and carbon, that is there. So we're going to be analyzing both the hydrogen and the carbon that's in the sample. Okay, so let's start with carbon. Okay, carbon, we're going to find the mass of the element. In here, they give us the mass of the element for carbon. In this case, is 41.33 grams. So we have the mass of the element right here. Okay, 41.33. Our total mass is right here. This is what they give us, the total mass, divided by 50 grams. Okay, and of course times 100. And that should give us a value. But keep in mind, you guys, that we're looking at sig figs. So this is 3 sig figs, 1, 2, 3. This is 4 sig figs, 3 sig figs again. So our answer is going to have 3 sig figs in it. Okay, so your answer should come out to be, when you put this in your calculator, it should be 82.7% carbon. Hydrogen should be the same way. For hydrogen, you've got your sample that you're given for hydrogen in this case is 8.67 grams of hydrogen out of a total of 50 grams for your total sample times 100. When you do, you should get 17.3% of hydrogen. Okay, so we found the percent composition in this formula of a hydrocarbon, where 50 grams of the hydrocarbon is present, 82.7% of it is carbon, and only 17.3% of it is hydrogen. Okay, and again, remember we could always do 100 minus 82.7, and that should give you the remainder of whatever is remaining. In this case, what's remaining would be hydrogen right here. Okay, so they should check out. And again, we could always add up 82.7 plus 17.3. That should equal 100%. That's a great way to check. Okay. Okay, so let's go to the next page. Okay. And in the next page, we have here, what is the percent composition of barium iodide dihydrate? And remember, this is a dihydrate problem. This is a hydrate problem. And for hydrates, you just find 2% for the compound and for the water. Okay. So let's get started on this. Again, we need to find our molar mass for our entire compound. So we have barium iodide, and this is dihydrate. So this is our formula that we can write. Okay. And so what this is saying is that when we find the molar mass of this, I'm going to find the molar mass right here. I've got 1 barium. Using your periodic table, the mass of 1 barium should be 137.33 plus 2 iodide, and that should be 126.91. Okay, and of course you've got the mass of plus you've got the mass of water, which is this is for barium iodide, and so for H2O, I've got 2 hydrogens. Each hydrogen is 1.01 plus 1 oxygen, which is 16. And when I add everything up, I should get, well, if you want to add it up separately, the barium iodide would be 391.15 grams per mole. And waters, of course, in this case, you have water, but keep in mind, you guys, that 18.02, but keep in mind that you have 2, so you can multiply it by 2. Okay. Okay, so that should give you here 36.04 grams per mole. Okay, so this is, we're actually going to be adding up 391.15 grams per mole plus 36.04 grams per mole, and when you add everything up, you will get 427.19 grams per mole. So that's your molar mass that you have here. Okay? So in here we are trying to find what percentage of barium we have and what percentage of the hydrate we have. So we're going to start off with barium iodide right here. And of barium iodide, we have here 391.15. That's the mass of our barium iodide out of the total 427.19 times 100, and that gives us 91.56% of the sample is barium iodide. Okay. Now for water, we could do it a little differently. Again, we can do it 100 minus 91.56, and that should give us 8.44% of it should be water. Okay, well, let's check that out. Let's see if it really is. So let's put H2O over here, and we're going to calculate it. Now, remember, we have 2 moles of H2O, so it's really 2. So we're going to put 2, and the mass of our H2O is 18.02, so it's 36. So really, this is 36.04 grams divided by our total mass, which is 427.19 times 100, and you should end up 8.44% of H2O. Okay? So it does work out that in this sample, only 8.44% of it is water. The rest is barium iodide. Okay, so this concludes my lecture on percent composition. Hope this helped you. I'll talk to you guys later. Bye.